Hello everyone, my name is Breana Goldman and I'm a mentor teacher at McGarry Middle School. In today's lesson, we're going to focus on calculating percents in everyday life. We're going to focus on using proportional relationships in order to solve real-world problems with percents. 7th graders, this should be a review for you. You should have already learned this lesson at some point during this school year. However, it's a great review to prepare you for 8th grade or to also help you with your virtual assignments if your teachers are assigning you any real-world problems that involve percents. 8th graders, this is just a great review for you. Let's first start by thinking about the why. Why do we need to learn about these problems involving percents? When do you encounter percents in your everyday life? I want you to take the next 10 seconds, talk with your families, and think about where do you see percents every day. What'd you come up with? Did you think of any of these? When you go to a store, you get discounts. You can use coupons to get certain percentages off of your total. Maybe you have to calculate your sales tax to make sure that you can fit within your budget, your purchase. Or maybe you've got a favorite sports team and you're constantly keeping track of their stats and percentages of making goals, of making baskets, whatever it is, percentages overwhelm sports data. Today's focus is going to be on solving those problems with percents. We're going to focus on tax, gratuity, commission, and discounts. We first discussed the why, but now let's dive in deep into our strategies. We're going to watch a math antics video that shows us exactly how to use proportions to solve percent problems. This is probably how your teachers taught you to do these problems this past school year. We're going to explain some other strategies when we're looking at problems with multiple steps that you may or may not have seen before. You're going to try some sample problems on your own, and then I'm going to give you ways that you can practice this at home. Let's get started. With any percent problem, there's 3 important parts. And missing one of these 3 parts is what we're trying to do, or is what we're trying to figure out when we're solving these types of problems. This Math Antics video is going to detail those 3 missing pieces. So as you're watching this video, I want you to think about this question. Which 3 missing pieces could we be asked to find in any percent problem? Take a look.
Hi, welcome to Math Antics. In this video, we're going to learn how to do another common type of problem involving percents. We're going to learn how to figure out what percent is it. In our last video, we learned how to do a really common percent problem, which was finding a percent of a number. For example, we learned how you could solve a problem like, what is 20% of 50? And the answer to that problem is 10. So we could say that 10 is 20% of 50. Let's look closely at that statement for a minute. Notice that there's 3 different numbers in it, 10, 20, and 50. And that's because a percentage is really a relationship between 3 numbers. Well, actually it's a relationship between 4 numbers, but the 4th number is always 100, so you always know it. To see what I mean, think back to our video about percents and equivalent fractions. In that video, we learned that a percent is really an equivalent fraction that has 100 as the bottom number. So we could rewrite our statement like this. 10 over 50 equals 20 over 100. This is exactly the same as saying that 10 is 20% of 50. So these are the 4 components of a percent problem. But since we know that 100 is always going to be the bottom number of this equivalent fraction, the percent, we can just rewrite it using the percent symbol. That way we can focus on the other 3 numbers that can change. And we're going to give each one of these 3 numbers a name so that we don't get confused. We're going to call the top number of the fraction the part we have, or just the part for short. And we're going to call the bottom number the total. And we're going to call the number in front of the percent sign the percent or percentage. And since there's 3 different numbers that can change in a percentage problem, that means there's 3 different questions that you can ask. To see these 3 questions, let's rewrite our original statement 10 is 20% of 50 3 different times. But in the first statement, we replace the 10 with the word what, and it becomes what is 20% of 50. In the second statement, we replace the 20 with what, and it becomes 10 is what percent of 50. And in the third statement, we replace the 50 with what, and it becomes 10 is 20% of what. Doing this is helpful because whenever you're given a problem involving percents, the first thing you need to figure out is what the problem's asking you to find. You know, which number is missing. In the first statement, the part we have is missing. In the second statement, the percent is missing. And in the third statement, the total is missing. And these three statements represent the three most common types of percentage problems. The first type is what we learned in the last video, finding a percent of a number. In this type of problem, we know the percent and we know the total, but we don't know what part of that total we have. The second type of problem is what we're going to learn in this video. In this type of problem, we know both the total and we know what part of the total we have, but we need to figure out what percentage of the total that part is. We need to find what percent is it. And the third type of problem is what we'll learn in the next video. For that type of problem, we know what part we have and we know what percent of the total it is. We just don't know the total itself. Have I lost you yet? Don't worry. It'll make a lot more sense after we look at a few examples. So, let's look at an example of a type 2 problem, where we know the part we have and we know the total, but we don't know what the percent is. This example is a word problem, and it says, your uncle, who really likes to travel, has visited 35 of the 50 US states. What percent of the states has he visited? The key words in this problem are what percent, because they let us know that it's the percent that's missing. So the two numbers that it gives us must be the total and the part we have. Well, in this case, it's not really the part we have, it's the part that our uncle has visited, but you get the idea. And sometimes it can be hard to tell which number the total is. Often it's the bigger number, but not always. And that's where the word of can help us out. The word of usually goes in front of the number that's the total. So when you see of the 50 US states, it's a clue that 50 is the total. All right then, so we put 50 on the bottom of the fraction and 35 on top. Now we're ready to figure out the part that we don't know, the percent. To find the percent, all we need to do is convert the fraction into its percent form. That means we need to convert it into an equivalent fraction that has 100 as the bottom number. Well, one way we could do that would be to look for a number that we could multiply both the top and bottom numbers by that would change the bottom number into 100. Well, the number 2 looks like it would work. If we multiply the bottom by 2, 2 times 50 gives us 100, and then we also need to multiply the top by 2, and 2 times 35 equals 70. So now we can see that 70 over 100 is equivalent to 35 over 50. And since 70 over 100 is just 70%, it means that our uncle has visited 70% of the states. And all I got was this lousy t-shirt.
Okay, so which three missing pieces could we be asked to find in any percent problem? He talked about the relationship between four numbers, one of those numbers being 100. Let's think about those three pieces that we could be asked to find. We could be asked to find the part, the total, or the percent. Did you get it right? Let's show the relationship between all three of these pieces by setting up a proportion. Remember, as he talked about with equivalent fractions, a proportion is just setting two fractions equal to one another to find a missing part. To set up our proportion, we're always going to have 100 on the right side. That's where our percent is going to go here in just a second. Our part is going to go in the numerator of our first fraction. Our total is going to be the denominator, and our percent is always going to be that number over 100. This proportion is going to be extremely important for us to solve the rest of these problems. So, if you're taking notes right now, grab a pencil and a piece of paper and jot this down so you can reference as we're practicing the rest of the problems. I'll give you the next couple seconds. As we go into starting the next couple of problems, these notes will be helpful to you as well as a calculator, as long as your teacher has advised you that it's okay to use one with these types of problems. So let's take a look at our first problem. Serena is a realtor who sells a house for $142,000. If she earns 3% of the house's price as a commission, how much is her commission? With any real-world word problem, let's first digest our different important parts that we're going to need to use in order to help us answer the question. First, we have $142,000. We see that that represents the cost or the price of the house that it's sold for. For solving percent problems, obviously our 3% is going to be extremely helpful to us. And we see that 3% represents her commission. Remember that commission is an amount that someone gets based on the sales that they make. The question that we're being asked is, how much is the commission? So let's take all of these parts and set them up into our proportion. The $142,000 is going to be classified as our total. That's the total price of the house. Our 3%, as with always, that percent's going to go above 100. This means our question asking us how much is her commission, that means we are missing the part. This is the type of problem where we're missing the part of our proportion in order to figure out our problem. In the Math Antics video, he used equivalent fractions in order to solve the problems. The fractions that he was using were relatively simple, and these numbers aren't going to be as easy to find. Therefore, we're going to cross-multiply to solve these proportions instead of using equivalent fractions. So to cross-multiply, we're going to take x times 100 and 142,000 times 3 and set those equal to one another to make this equation. To simplify the right side, we'll multiply those two numbers to get $426,000. In order to solve for x, we're going to divide both sides by 100 to find that x equals 4,260. Now let's go back a second. What did x represent? X represented how much her commission was. So to answer our question, Serena makes $4,260 in commission from the sale of the house. Let's take a look at another problem. Carissa is shopping in Illinois, where the state sales tax is 6.25%. She paid $3.56 in sales tax on a shirt that she bought. How much did the shirt cost before tax? Again, let's break down our important parts from this problem so we can figure out what we're looking for. 6.25% is going to be an important part. That represents the percentage of sales tax for the total. $3.56 represents how much she paid in tax. And our question is asking us for the cost of the shirt before the tax. Let's take a look at all of those parts, all of those pieces, and put them into our proportion. 6.25% is going to go above that 100 to complete our percentage fraction. The $3.56 isn't our total cost of the shirt, it's a part of that cost. So therefore, it's going to go in our numerator. That means that we're looking for the shirt's cost, which means we're missing the total. This is a different type of problem than the last. So just with our last proportion, we're going to solve this by cross-multiplying. We're going to multiply $3.56 times 100 and x times our 6.25 to get this equation. We're going to multiply the left side to get 356. And to get our x by itself, we're going to divide both sides by 6.25. We'll then see that x represents 56.96. But what does that mean again? Let's go back up to our question. We were looking for the cost of the shirt before tax. Since we found that 6.25% was our $3.56, we find the total of that was $56.96. Therefore, to answer our question, before tax, the shirt that Carissa bought cost $56.96. These two problems, along with the problem that was in the video, have covered missing the three different pieces: the part, the total, and the percent. Now we're going to take a look at some problems where we're going to have to do several steps in order to get our final answer. I'm also going to show you some strategies that maybe you've learned or maybe not to help you in solving these a little bit easier. Terrence is eating at a restaurant. His bill comes to $15.10, already including the tax. If Terrence only has $18, can he afford to tip the waiter 20%? Let's figure out our important parts to this problem. We know $15.10 is going to be important to us because that's how much his total bill was, including the tax. We know that the 20% is going to be important to us as we're trying to find 20% of that total. We're going to ignore the $18 right now because we first need to answer this question: can he afford a 20% tip before we can analyze whether or not he has enough money? So let's put these important pieces into our proportion. The $15.10 is the total of his bill. We're trying to find 20% of that total to see if he can afford the tip. Therefore, we're trying to figure out that part. How much is the tip if he uses 20%? When we cross multiply and simplify, we come to the equation 100x equals 302. To get x by itself, we're going to divide both sides by 100 to find that x equals 3.02. If we go back up to our question, we see that the part that we were trying to find was the tip. So our $3.02 represents the tip. Our big question is, if Terrence only has $18, can he afford that tip plus the total? So we have to take the total and the tip and add them together and compare it to the $18 that he has. When we do that, we see that his grand total would be $18.12. So to answer that question, no, Terrence's total with the tip is $18.12, which is more than the $18 he has. Maybe he's got some change in his pocket that he didn't know about and can finish that off. This type of problem, we had to find our percent, then we had to take that and add it to our total. In this problem, we found the amount of the total, which was given, and we found the amount of the tip and added them together at the end. There's another strategy that we can use to solve this exact problem, but changing the addition part and doing it up at the top. So this time, same problem, but notice that that percent is 120% this time. How did I get 120%? Well, I knew that I was going to have to take my tip and my total and add them together. Instead of doing that after I found the amounts, I used the percentages and added those together. I knew that the tip was going to be 20% and my total represents 100%. So I took those percentages, added them together to get 120%. Now when I solve for x, I'm not just looking for the tip, but I'm looking for the tip and total added together. So when we cross multiply and do all the rest of our work to solve our equation, we find that x equals 1812. I've already done that extra step at the beginning, so that gives me my new total. Let's take a look at another problem, similar strategy as the last one. Caden is looking to buy a video game. The store has a 15% off discount on the game. If the game costs $59.99, what will be his pre-tax total after the discount? So we know the price of the game. We know that it's going to be 15% off. And we know that that price is before tax. We're not concerned about tax in this problem. Our question is, what's the total after the discount? Not what is the discount, but the total after the discount. We've got two parts again here. Setting up our proportion, our percent is going to go above our 100 again, and our total is going to be $59.99. We're missing the part. In this proportion, we're solving for the amount that's discounted. We're going to start there. When we cross multiply and simplify, we get the equation 100x equals 899.85. To get x by itself, we're going to divide both sides by 100 to get x equals roughly 9. It was 8.9985, which is going to round nicely to 9. But what does that 9 represent again? Well, 15% was the amount that we were discounting. So therefore, that $9 represents the discount. It's not his new price yet. That's just how much we're going to take off of the total. So to figure out what his pre-tax total would be after the discount, we're going to take that total of $59.99 and subtract off the $9. That's going to give us a new total of $50.99. So to answer our question, before tax, Caden's game will cost $50.99 after the discount. Just like we did with the tip problem, there's a strategy that we can use to where we wouldn't have to do this extra subtraction at the end. Instead, we could do it at the beginning with the percentages, and our final answer would go ahead and give us the total after the discount. Let's take a look at that here. So notice instead of 15%, this is the exact same problem, by the way, I'm using 85%. Where did I get 85%? Well, I knew if I had my total and I could figure out my discount, I'm going to have to subtract those to figure out my total after the discount. My total is going to be 100%, representing that big amount. My discount is 15%, so I can subtract those percentages to give me 85%. And when I solve this proportion, because I know that my price, my total after the discount, is 85% of my original total. Therefore, when I solve for x, it's automatically going to give me that total after the discount. It's going to give me $50.99, just like we saw was the correct answer in the last slide. You can decide which way that you prefer to do this. If you like this strategy and want to take a second to write it down, here's maybe some notes you'd like to take. Remember that when you're trying to calculate for tip or tax, and you're looking for the total after the tip or tax, you're going to add those numbers to the total. If you're calculating a discount and the question asks you to find the total after the discount, you're going to be subtracting that discount from the total. That's how you're saving money. Remember that you can add or subtract. You can do these operations either at the end of the problem, once you've identified the total amount and the percent that you're either adding or subtracting, or you can do it at the beginning of the problem with the original percents and add or subtract the percents that you have. I'll give you the next couple seconds to write this down if you'd like before we try some problems on your own. Now it's your turn. I'm going to give you a chance to try some of these problems on your own. Ryan is looking to buy a beanbag for $54.99, and he has 2 coupons. He can only use one of these coupons because they can't be combined. Which coupon would give him the best deal, and what would be his total? And I want you to explain. I'll give you the next couple seconds to try to figure out which of these 2 would be the best deal to help him save the most money on his beanbag. So, which one's the better deal? If we take a look at the 20% off, we can solve this proportion. Notice I used the 20% instead of 120%, so I could figure out the discounted price. Sorry, that would be 80%, not 120. We're subtracting that amount. I used the 20% so I could figure out the discount instead of the total price after the discount. When I solved this, I found that the discount would be $11. or his total would be $43.99. Seeing that this coupon is just a flat $10 off, we would know that the discount would be $10 and his new total would be $44.99. So to answer the question, which one would be the better deal? The 20% off is definitely going to be the better deal. Ryan would save $11 versus $10 and his total would be cheaper. Let's take a look at another problem and see how you do. Maria and Demaya go to dinner in a town with no sales tax. They only have $31 to spend. Their bill before the tip is $25.98. Which tip amount can they choose to leave? They've used one of those little electronic devices where they swipe their card, and now they have these two options for a tip. Remember, they only have $31, so which tip can they afford? I'll give you the next couple seconds to figure out the answer. So which one do you think? If we look at calculating 15% to see what the tip would be, we would find that the tip would be $3.90 for a total of $29.88, which they can definitely afford. Let's go ahead and take a look at the 20%, because if they can afford it, why not give the waiter 20%? When we find 20% of the $25.98, we see that that's going to give us $5.20 for a total price of $31.18, which they can't afford. The 15% tip is going to be the one that they can handle. I'm going to skip Nathan's problem now just for the sake of time. But let's just take a second to review. We looked over the why we need to solve percent problems. We used proportions to solve percents. I gave you a couple possibly new strategies that you can think through to help you solve those multi-step problems. And now I want to show you how you can practice this at home. If you're looking for some more videos, check out YouTube and type in Math Antics Percents, and you'll find his percents playlist. You'll not only find the video that I've already shown you, but the video before and after in this series, and a couple of others if you need some more help. If you search Khan Academy percent word problems, you'll find some videos that detail almost any type of percent problem you can imagine, along with some example problems. If you're looking to practice this at home, grab an ad, grab a newspaper, look on your phone, and go shopping with your family. Go on a pretend shopping trip. Buy some items, use discounts and coupons, and calculate 7% in Indiana tax. Maybe you're planning a party. You've got a budget, and you're trying to figure out who can buy the most amount of items under that budget. If you're looking for a game, if you go to mathplayground.com and percent shopping game, you're taking items and you're figuring out discounted prices with those. Mathgames.com and search percent of a number, tax, discount, and tip. You're going to find more example problems like the ones that we've done. Or you can check out the quizzes that I've put together by following this link, bit.ly/percent quizzes, to try that quizzes. Show your teachers what you know and what you've learned about percent word problems. Thank you for watching today.